Now, with this, I'll quickly move to Professor Palodhi. Right, we all have been knowing, right, since our graduation days, physics is the mother of all subject. Now, as AI becomes increasingly accessible, students often wonder whether traditional subjects like physics are losing relevance or not. Yet many of the today's more transformative technologies, including semiconductor, like as Professor Nondi said, quantum computing, photonics, robotics, satellite sensor, batteries, medical imaging, and advanced communication systems are fundamentally built on physics. AI may accelerate innovation, but the physics continues to provide that scientific foundation that makes these technologies possible. So my question is, with your vast knowledge, students often ask whether foundational subjects like physics remain relevant in an AI-driven world. How important will physics continue to be in shaping future technologies? Over to you.
Okay, so uh, I would take recourse to yeah, I would take recourse to Richard Feynman. So who said yeah, instead of me being the culprit here, let me quote a big fellow. So Richard Feynman actually believed that everything is physics. Okay, so everything. So how everything is physics? So biology. Let's start with biology because Professor Lahiri is here. So biological systems are nothing but clusters of different atoms. Okay,
Correct.
which behave in a different way than atoms do. So so from there, if it is atom, then it should be obviously related to chemistry, and
Right.
if it is related to chemistry and we go to atoms and molecules, then obviously it would be physics. So
Absolutely.
in fact he went on to, I think famously, those who have read Richard Feynman's book, he has had a glass of wine, and he said that within this glass of wine I can see the universe, and universe is physics. So
Correct.
therefore so be that way, but I would say that physics will remain relevant. But here we are talking not about whether physics is going to be relevant, but whether physics is going to be relevant in the sense whether it would generate different jobs, it would
Absolutely.
generate business.
Mm.
So already the conversation which we are having, it is happening due to physics. So obviously I expect that Zoom is employing thousands of employers, so thousands of employees. So therefore obviously it is being the way we are able to visualize each other is through a CMOS camera, which is
Correct.
due to physics. The light which is just now shining on us, it's due to physics. So therefore let's not debate whether physics is going to be relevant, but the way physics is taught, or in fact for that matter the way our students are being taught, that
Hmm.
has to change, so that
Absolutely.
the students can become, uh, as I think our previous professors already said, that they can become more self oriented. When someone is employing them, they can be proactive.
Correct.
When we were growing up, we were 80s kid. So in our house, if there was a spark plug or something fuse, we used to replace them with a small screwdriver and everything. Now what is happening is, now the entire building is concealed wiring, only we can see the switchboard. So therefore that hands-on experience of dealing something, correcting something, repairing something, that is getting lost. But in addition to that, now students or kids are more exposed to a lot of gadgets.
Correct.
So therefore with those gadgets, they can actually explore a lot of things. So I think what my experience in being in other country and learning their experience from them, so I saw that a class 6, so in UK I saw that a class 6 students group, they were sent to see a car. Okay,
Oh.
and with the measurement tapes they had to measure how much is the width of the dicky or trunk, or what is the measurement of width. Now in our lab where I used to work, there was this demonstration of BTech students who were seeing Fourier series, which
Wow.
are essentially sine waves. Okay,
Mm-hmm.
so what they were doing is they were strumming the guitar, and those
Mm-hmm.
guitar, there was a audio sensor which could have put into the CRO, and they could see. But
Mm-hmm.
when they were asked, write down the Fourier series, F0, A, cos,
Mm-hmm.
n, omega, and all those, they couldn't. But
Oh.
Indian students would do it.
Mm-hmm.
Japanese students would do it. Chinese students will do it. Okay, so Asian students are inherently good in maths, calculating. That skill is inherent to us, and
Mm-hmm.
that is due to the way we learn.
Correct.
More theoretical, but we need to understand that only theoretical learning has taken us to up to this level. We are
That's
almost like software is synonymous to India. So
right.
the theoretical knowledge, the number of papers we generate, you will see mostly theory.
Mm.
We have very few experimentalists in India, very few actually hardcore engineering papers or patents coming out from
Excellent.
India,
Excellent. Yeah.
because we do not have that hands-on skill. Technology comes from bottom, science comes from top. So therefore, if we need to build something,
Mm-hmm.
then we need to get our hands dirty. We need to send students, teachers, our own kids to go into the actual society, buy certain things, do something, make something, build something.
Absolutely.
I think what is missing now, when we were growing up, we had to mix in the society. From that society, we would know what would be a problem, and that problem could be an opportunity to an entrepreneur or an engineer or a physicist. So
Brilliant.
that is where we are lacking. We need to send our students away from classroom
Right.
and go to the actual society, make some positive changes, be it an instrument, be it something else. Otherwise, we would be lacking behind. No chat GPT, no
Mm.
growth will come from us.
Correct.
Because actually, those who are getting their things dirty and are getting their hands dirty to make certain things, they will know what are the problems they are facing. So
Excellent.
what we are building, our entire generation of students, I think up to, so when we were growing, our entire curriculum was based on mostly theory, but we had the experience of going out. We had
Right.
to face difficulties, so that experience was there. But our kids, our students are mostly coming from a relatively higher background.
Right.
We were coming from modest background, they are coming from a relatively upper background, so therefore they are not facing those problems, they are
Mm.
not facing those challenges. So that, I think, is the fundamental thing. So that is one part which I would like our students. So therefore, those students who are getting exposed to different softwares early in their career, different instruments early in their career, they are able to build a very, very important career around their specialization. So that's one
Brilliant.
part. This is about teaching. Secondly, coming to what will happen to quantum and photonics or physics. Currently, photonics industry around the world is touching 1 billion. In 2030, it is going to be 1.3 billion. China is occupying about 500 billion, so half of it. Okay, because China has done a lot of research, reverse engineering to build things, and these building things have enabled them to generate the next generation of factories where there is not a single person working. So they have started with many people factory to a no people factory in a matter of 20 years. So
Wow.
therefore, even US is sort of they are sort of scared the way Chinese have been developing, because it is the specific knowledge of building hardware. I think Professor Nondi mentioned about advanced manufacturing.
Mm-hmm.
Yes, advanced manufacturing. Let me give you a very, very simple idea, because World Cup is going on. I think the workflow will be understood, and then I'll stop. So photonics is about 1 billion. Quantum is deemed to touch about I think about 1 billion or something like. Photonics is a 1 trillion. I beg your pardon. So therefore, all these technologies come up. Many recent startup is coming up. Now, let me very recently there was a lot of hallagulla about a particular ball. How
Hmm.
whether it has touched the hand of a footballer. I am not naming the teams here because there can be different supporters. So therefore, they have used this technology of sneakometer, which
Correct.
we used. Now within the ball, so previously, and let me bring in the photonics perspective also. So we see the ball through a zoom lens. Now earlier zoom lens had to have about 4 to 5 lenses. Now it has about 8 lenses. So you see the zoom lens's size of the zoom lens is getting bigger and bigger. Now with the zoom lens, now there is automatically connected CMOS chip which is connected to a program. So therefore, whatever resolution or enhancement or difference in that can be done. So through this, people can see very closely whether there is a foul, whether the ball has touched. Despite that, there are certain confusions. So within the ball, there is a sensor which can minutely sense whether there is a very small touch or very minute touch to the ball.
Right.
So therefore, what is happening here? A workflow which was predominantly based on imaging, now it had to employ a sensor to the actual object. So
Right.
this is how the entire workflow is getting built up. People who are actual footballers, actual coach, they are being employed to modify this or optimize this technology. So
Correct.
there would be always place for experts. And
Right.
to be an expert, our students are spending their time on clearing different exams, IIT, NET, and UGC, NET, and all this. Whereas in elsewhere, in Western countries, from class 8, they are going for internships. So
Right.
this is the fundamental thing. Because they are going to internships, they are building skills very, very early, and they are becoming expert. To be an expert, you need not clear exams.
Correct.
What we are having is, as I think Professor Nandi told, we are having multidisciplinary knowledge because our course structure in any engineering is built on a lot of things. But to be an expert, you have to discard a lot of things and go into a very special domain. Otherwise,
Correct.
it is not possible. So
Brilliant.
next generation of students have to be experts in their field and not a jack of all trades. So that is the fundamental thing which I would close on. Okay.
Brilliant. Brilliant. Thank you so much, sir.